Hello everyone. In this video we will discuss some of the synchronization techniques that are needed for thread safety in a multi-threaded programming in Swift. We'll discuss locks, NS locks and semaphores in this video tutorial. First let's look at the problem and then we will see why these synchronization techniques are required in a multi-threaded programming. So generally what happens, imagining a scenario where multiple thread needs to access a shared resource. It could be a database or a network connection, however accessing a resource concurrently without proper synchronization. So what happens, it can lead to a data corruption, inconsistent results or conflicts. For example, you are accessing a database, a core data or something where you have two different threads happening concurrently. One is writing the database and one is reading the database. So what happens, there could be a data corruption. It can lead to a data corruption and inconsistent results or conflicts. Correct. So we need some synchronization techniques which will allow synchronized access to shared resources, preventing data corruption, inconsistency and conflicts so that may arise from concurrent access. So which usually provide a mechanism to limit the levels of concurrency, regulate access and maintain the integrity of shared resources in concurrent programming scenarios. So that's basically the problem we usually have in a multi-threaded environment. For example, let's say this is example, we have a class counter where count being the shared resource. We have two methods, increment and decrement, which increments and decrements the count value respectively. So I have created an instance of the counter, and there is a multi-threaded environment. This is thread 1 and this is thread 2, let's say, which is performing concurrently. For iterations of 10 we are incrementing the counter, and for iterations of 5 we are decrementing the counter. That means at the end what would we expect the value of the count, this particular count, to be frank, 5, correct? It is starting from 0, incrementing 10, and we are reducing it by 5. So I would expect a value of 5, but let's see, two threads are accessing a shared resource. This is the shared resource. Two threads are accessing it concurrently. So now see what happens. Let me run it and see. So first time I ran it, the final value is 5. Second time the final value is 5, which is good. Third time the final value is 5, which is good. Fourth time the final value is 5, which is good. Fifth time the final value is 5. Sixth time the final value is 5. Seventh time the final value is 5. Eighth, 9th, 10, 11. So why 10 times it worked fine and the 11th time it failed? Okay, now again 12, 13, 14, again it failed. 15 failed. 16, fine, it's fine, it's fine. So we need to run it multiple times. Why? Because it is giving odd results sometimes, correct? So this code is obviously not reliable. It's not giving the expected value 5 all the times. Why? Because a shared resource being accessed by two threads concurrently. So that is the reason a data corruption can happen. That is the actual problem in concurrent access to a shared resource. Okay, this shared resource could be a database, a network connection, or could be anything. So this count is going wrong. End of the day, if I see my count, it is 5 most of the times, which is good, but it's 4 sometimes. So end of the day, it's not a reliable code. So how to make it a reliable code? So here comes the synchronization techniques. So it is not a thread safe code. What you have written, this is not at all a thread safe code, correct? So this code is not thread safe. We need to make this code thread safe. How can I make this code thread safe using the logs, NS logs? So Foundation framework has given us NS log, which is a primitive synchronization. NS log is a synchronization mechanism provided by the Foundation framework. Typically we can create like log is equal to NS log, which is provided by the Foundation framework, starts with NS. In Swift, to protect shared resources and ensure thread safety, it allows you to synchronize access to critical sections of the code, preventing multiple threads from accessing the same code block simultaneously. Then let's see how. So typically what we do is we lock the resource access. So I locked it. Now once I am done with the counter, what I do is I do unlock. I am not doing any great thing here. What I am doing is we have a counter class that manages a count value. The increment and decrement methods are responsible for modifying the count value. Correct. To ensure thread safety, we use an instance of NS log called lock. Inside the increment and decrement methods, we acquire the log by calling the log. Here I acquired the log. So I do the same stuff here also. If I need to decrement also, I need to lock my user so that other thread will not increment it, will not access it typically. Log dot unlock. So in both increment and decrement methods, we acquired the log by calling the log dot lock before accessing the shared resource, which is the count, which ensures that only one thread can execute the critical section of the code at a time. This is the critical section of the code. This is the critical section of the code. Only one thread can access the critical section of the code at a time, which is shared resource. After modifying the count value, we release the lock. By calling the unlock. Releasing the lock allows other threads waiting to acquire the lock to proceed. That means releasing the shared resource. In this example, we use dispatch queue concurrent perform with the iterations just to simulate the scenarios. By using the NS log, we ensure that the count is incremented and decremented safely, preventing data races and inconsistencies. And NS log is a simple and effective way to synchronize access to shared resources in Swift programming language. However, it is important to use it judicially to avoid potential deadlocks or performance bottlenecks. Logs, of course, we are using, and these are helpful, but we need to use them very carefully, otherwise these will end up with deadlocks. How they will form a deadlocks and what is deadlocks we will discuss in some other tutorial. So let's see whether using logs, whether we have made this code thread safe or not. That means anytime I run it, the counter.count should always be 5. Okay, so let's run it for a couple of times. It should be always 5. It should not give you any other value. Why? Because it's going in a fashion. Why? Because if you can see also, it first got incremented and then it got decremented, and the final value of count is always 5. So that's where every time it will give only 5. Let's run it couple of times. I think I ran it around 7-8 times. Let's run it for some 15 times. So let's see, it will never ever give you unexpected value. Correct? That means this code has successfully become we have made it a thread safe code by using NS log. Fine. So that's basically how logs work, which is given by, it's a primitive synchronization technique. The synchronization is needed. Why? Because if we don't synchronize, write may override read, read may override write, so you will not get the expected value. So you need to log the critical part of the critical piece of code, which is the shared resource. Okay, now logs we explained. Now let's see let's make this code, roll back the code. So that means it's not going to be thread safe again. Let me remove the logs. So again, it's not a thread safe code, and you can run it and see it gives 5 sometimes and it gives 4 sometimes. So see, it's not a thread safe code. Okay, now let's come to Semaphores. Semaphores, it's exactly like let me roll it back. It's exactly like logs, but Semaphores having a little difference. Dispatch semaphore with a value. Here the value is nothing but how many threads can access a value concurrently. How many threads, whether one thread or through two threads. Here I want only one thread, only one thread. Why? Because the value is 1. Only one thread can access the shared resource at a time. So that is what we want, correct? So like log.log semaphores, what they will do is they ask the thread to you wait. So let me increment, and once the increment is done, the unlock is like signaling saying other thread can access the shared resource. That's it. That's the only difference. You wait for the resource, you signal that you are done. So apart from that, there is no difference much. So I'll wait for the shared resource, and then I signal you saying boss, you're done. Typically what happens, no, semaphores.wait, what will do is it will decrement the counter by 1. That means here the value will become 0. When the value becomes 0, so other thread checks this value, and as it is 0, no one can access the shared resource. So they will not if increment is happening, decrement will not happen. Again, when you signal it, what happens, no, value will get incremented by 1. Again the value will become the 1. That means now another thread can access this value. That's basically the funda behind this semaphores. That means it is using lock you can only allow it to one thread, but whereas using the semaphores, you can give, for example, you can allow like, okay, 2 threads can access the shared resource at any time, something like that. So though both locks and semaphores are for synchronizing during thread safety, they are having little differences. We'll discuss that in a separate tutorial, but that's not the topic here. So semaphores is one of the synchronization techniques like lock. So like lock and unlock, we have wait and signal in the semaphore. So typically background what happens is the wait decrements the counter by 0. That means no one else can, if the value is equal to 0, no other thread can access the shared resource. If the value is 1, okay, one thread is allowed, any one other thread. The same thing happens here and here. Now let's see whether this is the thread safe code or not. So anytime if I run it, it should always give me 5 only. So it will give 5 only, there is note about it. So as if you can see, it's incremented to 10 and it got decremented to 5. So you run it any number of times. Let's run it for a couple of times like we did for ns log. It will give you the only expected value, and it will never ever give you the unexpected value. Why? Because it got synchronized. All increments happened 1, till then decrement waited, and all decrements happened then, correct? So even if you have some other multiplication, for example counter, you are multiplying something or any operations, they will happen in a synchronizing order. Okay, first you want to increment, and then you want to decrement, and then you want to multiply it by 2, something like that. If you want to do anything, if you have this synchronization, there are many synchronization techniques, like we can go with dispatch groups, dispatch queues, and there are multiple things, but ns logs, we're going to discuss only ns logs and semaphore in this particular video tutorial. And as you can see, using ns logs and semaphores, we successfully made a code which is not thread safe to a thread safe one. This is thread safe, correct? So, and it will never ever give you a unexpected value, and it will always go with the synchronized. So that is basically the problem, where in multi-threaded environment a shared resource can be accessed by multiple threads, and it will return in a data corruption, or it can lead to a race condition or something like that. So to avoid all this, we need to have some synchronization techniques when we are in a multi-threaded environment, especially if there is a shared resource that you are accessing, correct? Why? Because typically mutable things are very dangerous. Why? Because this is mutable, correct? It can be incremented, decremented changes. So a mutable thing is very dangerous in multi-threaded programming. To synchronize this, we need to go for a synchronization techniques. Not only locks and semaphores, there are other techniques also, but generally we use locks and semaphores. So that is the reason I am discussing only these two. I hope this example is pretty much enough to understand what is a semaphore and what is a lock. So basically in iOS development, a semaphore is also a synchronization tool used to control access to a shared resource by multiple threads. A semaphore is essentially a counter that is used to control the number of basically a counter that is used to control the number of threads that can access a shared resource simultaneously. In Swift, you can use dispatch semaphore class to implement the semaphores to limit the number of concurrent network requests. This is the counter, it depends on the counter. So that's by using semaphores also we can limit the number of concurrent network requests or resource access. We can avoid overloading the network and ensure that our app is running smoothly. So we can limit the concurrent downloads using the semaphores. That means if you're downloading something and your downloads has to happen one after another, not at a time, then we can go for the semaphores, correct? Or we can mention like how many concurrent downloads should be happening. That we can do using the semaphores. Let me give a value 1. So this is one example. So let's get into another example with the same stuff, so that you will better understand locks and semaphores. So this is one example. Let me bring another example for you. Okay, I have made the code ready. So instead of wasting the time writing the code here and wasting the time, so for example we have a print manager. For example, let's say there is no lock, and okay, and we have a print manager class which is printing a document. Printing document started, and it will take, let's say, some 2 seconds or something, simulate the printing time. Printing document completed. So this is a task, and for example I'm doing it for an iteration of 5 times. I'm printing 5 documents. Now what happens if it's a multi-threaded environment? 5 things are happening. See, basically we have a print manager class that simulates printing documents. The print document method is responsible for printing a document. We use an instance of NS. We can use an instance of NS lock or semaphore in this also. So what happens if there is no synchronization here? So what happens? Let's see what happens. See, everything got started and they're completed, but look at the order, correct? This is okay, but what if I want this to be in an order? Then I think we need to have the lock funda, where first this piece of information I am locking it, printing the document, this piece of code I am locking it. That means this operation needs to be completed, then only other thread can access it. Now look at what happens. Started document 1, completed 1, started 2, completed 2, started 5, completed 5, started 3, completed 3, started 4, completed 4. Of course I understand it's not 1 2 3 4 5, but it is the order is different. Why? Because these are concurrent operations, but when it is started, it has to be completed, then only it is going for the second document. For example, if this is the type of requirement that I need, then I can, this is kind of a synchronization, correct? Like I want, if you're starting something, if you're starting something, I want it to be completed to go for the next task. Document 1 started, document 1 completed, then only it went for other document, correct? So this so here we have used the lock before printing the document. This ensures that only one thread can execute the critical section of the code, which includes the print statement and the simulated printing time. This is the critical section of the code. So lock, we acquired the lock before the critical section of the code, and we released the lock after the critical section of the code. So after printing the document, we release the lock by calling unlock. Releasing the lock allows other threads waiting to acquire the lock to proceed and print their documents. So by using the lock, we ensure that only one thread can print a document at a time, avoiding conflicts and maintaining the order of document printing. Order. Remember that NS lock ensures exclusive access to the critical section of the code. If multiple threads attempt to acquire lock simultaneously, the additional threads will be blocked until the lock is released, which guarantees thread safety. Correct? So critical section of the code we locked using NS lock. So if you want to use the semaphores, replace locks by dispatch semaphore. Of course it's having a value I would say only 1. Why? Because I want it to be happen only one document at a time. Here again I do wait, you wait for, that means I am decrementing this value, that means no other thread, everyone should wait. Then let me signal you, I locked it, let me signal you, that means it's kind of an unlock. Now it's pretty same, 1 started, completed, 3 started, completed, 5 started, completed, 4 started, completed, 2 started, completed. See, there is a sync document order, whether you use logs or semaphores. For this is another example I would just like to show you guys, so that you better understand how in a multi-threaded environment, if you want, in the earlier example there is a shared resource, and in this example there is a critical section of the code, I want it to happen only once, one at a time. Correct? There is a difference between the previous example and this example, where there is a shared resource. In that example, where there is a critical section of the code, if I don't use the synchronization techniques like lock and semaphores, every document is getting started once and getting completed later. No, I don't want like this. I want it to be in a synchronized matter. You start one, you complete one, you start two, you complete. If you're starting a 5th document also it's fine, but you complete it, then only you go for the next document. Correct? So I hope the topic is very clear, how we can, what are the problems in the multi-threaded environment with respect to shared resource and the critical section of the code, and what is the problem and what is the statement, what is the solution here. We can use the synchronization techniques provided, like locks, which is provided by the foundation framework, and the semaphores. Semaphores are typical, where they go with a value, and unlike logs, you can allow 2 threads allow a shared resource at a time using the value. There are some differences which we will discuss in a separate video tutorial. I hope this post is helpful. Thank you.